So last chapter we went over trinomials and factoring them, and this chapter we're going to go over graphing them, which they're called parabolas when we graph. The first thing we're going to look at is a y-intercept. A y-intercept is where the line touches the y-axis, or where the parabola touches or intersects the y-axis. Now, if you look at this picture, they labeled the y-axis. It looks like it's on this dashed line, but it's actually right here. So this is your y-axis because this is where 0, 0 is. So this point right here would be the y-intercept. Do y'all see it? Okay. Now, there's a new word for something you already know. You guys learned what x-intercepts are, yes? Where it touches the x-axis. But when we're looking at parabolas, a lot of times they're going to call them zeros. Okay? So zeros are the same thing as x-intercepts. The zeros are also the solutions of trinomials. Also the solutions. So on your EOC, on your STAR test, they might say, what are the zeros? They might say, what are the x-intercepts? They might say, what are the solutions? Every single thing means the same thing with those three terms. So here we have an x-intercept, or also known as a zero, because this is where it's touching the x-axis. What is a zero also called? An x-intercept, also called a solution. Is there another zero? Yes. Right here, this is also a zero, also known as an x-intercept, also known as a solution. Okay, the next definition is called a vertex. The vertex is the lowest or highest point on a parabola. So the lowest or highest point of a parabola. If it's the lowest, we call it a minimum. Notice I put that right below the word lowest. If it's the highest, what do y'all think we call it? A maximum. So it just depends on the picture. So where do y'all think the vertex is on this picture? Right here. So this is the vertex, and would this be an example of a minimum or a maximum? A minimum. It's the lowest point it goes. It is a minimum. The axis of symmetry is your last definition, and it divides the parabola into two equal parts. You will not always see it drawn like this dashed line. So it's an imaginary line, so let's write that down. It is an imaginary line that separates the parabola into two equal parts. And it always passes through the vertex. It always passes through the vertex. So notice on this one, the axis of symmetry is passing through that vertex right there. Okay, so if you would go label right up here. Do y'all got all that already? Are we good? Okay. This is your axis of symmetry. So those are the main definitions that you need to know for the parts of a parabola. Now I want you to take your notes out. I apologize for the bad quality. The copy machine got a little crazy. But we're going to go through and look at what a parabola is and what the kind of questions that they're going to ask us about parabolas. Okay, here we go. A quadratic function, that's what these are called. So y'all heard me calling them trinomials, yes? Why were we calling them trinomials? Because there was 3 terms. But in specific, we're going to study quadratics. And quadratics are trinomials that are always in the form of ax squared plus bx plus c. A quadratic is a nonlinear function. What does nonlinear mean? Not a straight line. That can be written in standard form. So this is standard form. Every quadratic function has a U-shaped graph called a parabola, which is what we looked at. If the first term of the quadratic is positive, it's going to open up. So if this is a positive number, it's going to look like this. It's going to open up. It's going to be a happy face. If it's negative, it's going to open down. So pretend that this was opening down. It's going to be a sad face. So negative, sad, positive, happy. Make sense? Okay. It says if you have a quadratic parent function, y equals x squared, so the bx and the c are 0, what would this table be filled in? So where can I go in my calculator? So y equals, guys, they give you the equation, you go to y equals. So you're going to type in y equals x squared. Where am I going to go to see the table? Second. Find the word table, guys. I can't hear y'all. Second table, second graph. So second graph, here's my table. I'm going to go look when x is negative 3, y is? Anybody? 9. When x is negative 2, y is 4. When x is negative 1, y is positive 1. When x is 0, y is 0. When x is 1, y is 1. And when x is 2, y is 4. When x is 3, y is 9. Now, I want y'all to look at this. Do you see something where it starts to repeat itself? So, at 0, 0, do y'all see that it becomes symmetrical on both sides with the y's? Yes? That means this is probably the vertex. It's the middle. Because it's gonna be at the lowest or highest point, and then it's gonna repeat itself. That probably also means the axis of symmetry is going through this point, and everything is symmetrical on both sides. So let's go graph it and see. So I have negative 3, 9. Negative 2, 4. Do y'all see that point 0, 0 is the vertex? Yes or no? So right here, this is our vertex. So is it a minimum or a maximum? It is a minimum because it is a lowest point. And I can tell you that the axis of symmetry is going through that vertex. So the axis of symmetry is right here. Can I write an equation for the axis of symmetry? Yes or no? Yes, the axis of symmetry will always be x equals, because the axis of symmetry is always going to pass through the x-axis. Yes? Where is it passing through the x-axis at? So the axis of symmetry is at x equals 0. Now it says the lowest or highest point on a parabola is the vertex, the highest point on the y-axis is the maximum, the lowest point is the minimum. The line that passes through the vertex and divides the parabola into 2 symmetrical parts is called the axis of symmetry. The axis of symmetry can be found where it crosses through the x-axis. We've already gone over all of these terms. All right, now we're going to graph a parent function. We're going to add something to the parent function, and then we're going to compare the two parabolas, okay? All right, so it wants us to compare y equals x squared to y equals 3x squared. Well, didn't we just do y equals x squared? Okay, so I'm going to give you all the values. For y equals x squared, when x is negative 2, y is 4. When x is negative 1, y is positive 1. When x is 0, y is 0. And then it repeats itself. So I want you to go ahead and graph the parent function. So negative 2, 4. Negative 1, 1. 0, 0, 1, 1, and here. This is our parent function, y equals x squared. Okay, now we're going to go put in this function. For our second function, it's y equals 3x squared. So what did they add to it? They multiplied by 3. So let's go to y equals and type in 3x squared. Go to the table. When x is negative 2, y is 12. When x is negative 1, y is 3. 0, 0, 1, 3, and 2, 12. Do y'all see the vertex right here? 0, 0. So they share a point, 0, 0. So I'm just going to put a dot on top of that dot. Negative 2 is going to go up to 12. So I'm going to do my best. Here's negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be like right here. And negative 1, 3. Okay, do y'all remember those words we used to compare our functions the last time we did it? Vertical stretches, vertical shrinks, reflections. Do y'all remember that? Okay, we did it for exponential functions, right? Now we're going to do it for quadratic functions. So what did they do? They took the parent function, and what did they do? What kind of stretch? A vertical stretch. So to compare this, you would say they took the parent function and they performed a vertical stretch. So if you multiply by a number greater than 1, it is a vertical stretch, just like on exponential functions, okay? All right, what is the domain of this quadratic? We're going to talk about the domain of the new function, the 3x squared. What is domain? X to x. Is there ever going to be a stopping point, or is it going to slowly keep going out like this? Right? So the x's are going to keep getting smaller and bigger. So the domain is all real numbers. Because y'all agree it's going to keep going left and right, just very, very slowly. All right, what is the range? What does range mean? Anybody? What is a range? The y value. Is there a lowest point or highest point? There is a lowest point, meaning all the other y's are going up, which is greater than or? Because it's touching. And what is the lowest point it's touching at? 0. All right, let's find the axis of symmetry. So AOS, axis of symmetry. Where is the axis of symmetry? But it's got to be written as an equation. X equals 0. Does it have a minimum or a maximum? A minimum. It has a lowest value. And where is the vertex at? 0, 0. So those are all the questions that you will be asked today over quadratic functions and their parabolas. All right, now we're going to compare the same parent function, y equals x squared. So let's just copy down what we have for y equals x squared. So 4, 1, 0, 1, 4. And this time we're going to take that parent function and what are we going to multiply it by? Negative 1/4. What do y'all think the negative's going to do? Think back to exponential functions. What did it do? If we multiplied by a negative, what did it do? It flipped it, right? It did a reflection. And then what happened when we multiplied by a number less than 1? It did what we call a vertical shrink, but today it's going to be called a horizontal stretch, just because you're moving both of them. Okay, so let's go fill this in. So we're going to go to y equals. We're going to type in negative 1/4, tab out, x squared. And we're going to fill in our table. So when x is negative 2, y is negative 1. Negative 1/4, which is the same thing as negative 0.25. Okay, and the graph to this one's on the next page. It didn't fit. And yes, I know it's horrible quality, but that's what we got. All right, so let's go graph our parent function. When x is negative 2, y is 4. When x is negative 1, y is 1, 0, 0, and then it's just going to mirror on the other side. Now go graph the negative 1/4 x squared. So when x is negative 2, y is negative 1. And it looks like this. Okay, the first thing we're going to do is compare them. What did they do to the parent function? The first thing they did is what? We called it a vertical shrink, and you are correct for exponential functions, but we're not going to call it that today. So look what they did. They did it like this. They stretched it out, but instead of stretching it vertically, they stretched it. So this is a horizontal stretch. And then what did they do to it? They flipped it. What did we call that? A reflection across the x-axis. So what caused the horizontal stretch? Multiplying by a number less than 1. What caused the reflection? Multiplying by the negative. Okay, it's the same rules as exponential functions. We just call a vertical shrink a horizontal stretch. But let me say that again. Everybody look at the first two examples we did. When we multiplied by a number greater than 1, it caused a... If we multiply by a number less than 1, between 0 and 1, it causes a horizontal stretch. And if you multiply by a negative, it causes the flip, the reflection. Everybody good with that? Okay, now let's look at our parent function. Oh, we haven't finished, sorry. We need to do our domain, our range, and all that. So what is the domain of the new function, not the parent function? What is the domain of my pink one? All real numbers, because it's going to slowly keep going left and right. Yes? What is the range of my new function? Y is less than or equal to 0 because it's going below the 0. Does it have a minimum or maximum? We're only looking at my pink one. It has a maximum. And what is the axis of symmetry? X equals 0. Don't say 0, say x equals 0, because it is a vertical line passing through the x-axis. You want the equation. Now, the next example, we're going to take the same parent function. Do y'all see the same parent function, y equals x squared? So go ahead and fill in your table. When x is negative 2, y is 4, and then 1, and then 0, 1, and 4. But what are we going to do to the function this time? Instead of multiplying, what are we going to do? We're going to add. We did not see this with exponential functions. This is brand new. And in 8th grade math, y'all skipped, when you skipped 8th grade math, you skipped what were called transformations. So in 8th grade math, we teach reflections, rotations, translations, dilations. And so that's kind of a lesson you missed. And so this is going to be a new word for y'all. Okay, so let's go figure out, let's see if we can look at what happened. So everybody go put that in your calculator. So I'm going to put in x squared plus 5 and go fill in my table. So when x is -2, y is 9. And then go graph both of them. Okay, after you get them both graphed, I want you to look at them and see what happened. Bless you. What do y'all think happened? Did they stretch it at all? No. So what happened to it? They didn't stretch or shrink it. They are the exact same size. What did they do to it? Say that louder. They moved it. They took it and moved it where? Up how many units? 5 units. And what did we add to it? 5. They did not multiply this function by anything. That's why it's not a vertical stretch or a horizontal stretch. It was not multiplied by anything. When you add to the parent function, it is going to move it. It's called a translation, and that's the vocabulary you missed from 8th grade. So when we compare, when you add, it is called a translation. So it was translated 5 units up. It did not make it bigger or smaller. It didn't stretch it horizontally or vertically. It simply took it and moved it 5 units up. Do y'all agree? All right, what is the domain of the new function? All real numbers. Why? Because it's going to keep going left and right both directions just very slowly. What is the range of the new function?
Y is greater than 5.
Y is greater than or equal to 5. Why? Because that's the lowest point, meaning it has a minimum. What is the vertex of the new parabola? No, not the axis of symmetry. You're right for axis. What is the vertex? The coordinate that is the lowest point. 0, 5. Now give me the axis of symmetry. X equals, where is it passing through? X equals, guys, x equals 5 is over here. X equals 0. Why? Look right here. It's passing through, I'll use my highlighter. It's passing through the x-axis at 0. The 5 is the y-intercept. It has nothing to do with the axis of symmetry. Okay? Do y'all understand the difference? Yes or no? Okay, now we're going to do multiple things and see if y'all can figure it out. I want to just ask y'all, though, if y'all can figure it out. So everybody look at it. They took the parent function, y equals x squared. They did 2 things to it. What's the first thing they did? But they multiplied by a number less than 1. So what is that going to do? I heard you. A horizontal stretch. But then they also did what? Subtracted 4. What did we learn? When we added 5, it made it move up 5. They subtracted 4. So what do you think is going to happen? It's going to go down 4. So this is going to be a horizontal stretch, and it's also going to translate it down 4. Let's go graph it and look at it, though. So same parent function, 4, 1, 0, 1, 4. And then we'll go put this one in our calculator. Negative 2, negative 2. Okay, once you have your table, go ahead and graph it. Okay, let's compare. Did it reflect at all? Nope. But did it move it down? What do we call that when we move something down? Translated. So it translated 4 down. What else did it do? Y'all already said it. A horizontal stretch. All right, and we're going to skip domain and range. I think y'all got that. It has a minimum. The vertex is at 0, negative 4, yes? And the axis of symmetry is at x equals 0. Now let's look at 2-star types of questions that could be asked. Are y'all ready? How would the graph of the function y equals x squared plus 5 be affected if you change the function to y equals x squared plus 3? I want y'all to think about it and see if you can figure it out. So the parent function, they're not comparing it to a parent function, are they? They're saying if you started with x squared plus 5 and you changed it to x squared plus 3, what happened to it? It went 2 units down. Let's look at it. If I graphed x squared plus 5, it's passing through at 0, 5. 1, 2, 3, 4, 5 right here, and it looks something like that. If I take that function and I change it to x squared plus 3, it's going to look like this. It took the function and shifted it 2 units down. Could you have put that in your calculator, these two, and just looked at what happened? Yes. All right, now I'm going to pretend that this happened, but I want y'all to take off the m because it doesn't make sense for this problem in that second quadratic function. All right, so I'm going to read it to y'all and see if you can figure it out. It says, how would the graph of y equals x squared minus 3 be affected if the function were changed to x squared minus 2? Hold on, I want everybody to think. See if you can figure it out. Okay, what do you think? It's going to go 1 unit up. Why? Because it started at the negative 3 and moved to the, and to get from negative 3 to negative 2, it's shifting it a unit up, 1 unit up. Now again, if you're on your EOC, you could literally put these in your calculator and look at what happened to them. Okay? All right, let me get you your... If y'all would put your name when you get it, you are going to complete... Let's see. Well, let's just start going through it. Okay, on 1 through 4, you're simply going to fill in the question marks. So if you want, you can write it right below it, but you're basically going to put this in your y equals button and go to second table or second graph, however you want to write that. And just fill in the tables. Make sure you fill in the question mark parts, okay? All right, on 5 through 7, I personally would use my y equals button, put the function in, and I would use the table. I wouldn't use the picture of the graph to match it to these functions. You should already know which one this is going to be. Don't say it out loud. But what would make you know something like that? What do we learn? Say it. Yeah, the negative sign does what to a function? Reflects it, okay? But you just use your y equals button and then make sure that the coordinates line up. On 8 through 10, it gives you multiple directions, so you have to answer every part. The first thing it wants you to do is graph the function. What's the next thing it wants you to do? Identify the domain and range. So out here you should have D for domain, R for range. The next thing it wants you to do is compare the graph with the parent function. Now I'm not going to make you graph both of them, but compare it. You already know if it multiplies by a number greater than 1, it's a vertical stretch. If it multiplies by a number less than 1, between 0 and 1, it's a horizontal stretch. If it multiplies by a negative, it's a reflection. If it adds or subtracts, it's a translation. Yes? So make sure you also do your comparison. There can be more than one answer. Okay? On 11 through 13, you're going to identify the vertex and the axis of symmetry. The vertex is a coordinate, like 0, 0 or 0, 5. The axis of symmetry is an equation, x equals, and guys, are y'all ready for the trick? Whatever the x value is in the vertex, that's your axis of symmetry, x equals. So if it's 0, 10, it's x equals 0. If your vertex is at x 2, 3, then your axis of symmetry is at x equals 2. Whatever the x value is of the vertex, it's x equals that number. Okay, so that's what all three of these should look like. Flip to the back. 14 through 16, you're just matching these. You can use your table. You can use your y equals in your table, whatever you want to use. 17 through 19, you're going to graph the function, identify the domain and range. So I should have a D and an R, and compare with the parent function. You do not have to graph the parent function, but you do have to compare. We'll just do 1 through 19 for today. All right, you may start.